I'm Anil Kumar. Here are a few questions from review of probability which we had been doing. The question here is, a committee of 7 is to be chosen randomly from 3 students and 8 teachers. Construct a table to show probability distribution of the number of students chosen. What is the expected number of students on the committee? Now, whenever we're talking about selecting a committee, then in such cases, we know these are dependent events, since each person who is already chosen cannot be selected again, right? So these are all dependent events, right? And therefore, they qualify for hypergeometric distribution. So this is a case of hypergeometric distribution, where we'll treat selection of a student as a success. So we'll define our independent variable x as selection of student. Right. So if a student is not selected, we'll treat that as a failure, right? That is what it is. Now, a committee of 7 is to be chosen randomly from 3 students and 8 teachers. So we have 3 students, 8 teachers. So in all, we have 11, right? So, and a committee of 7 is being selected. So that is 11 total, right? So 11 is the total number. We are selecting 7. So selecting 7 means total number of in our sample space is, we are choosing 7 out of 11, right? So it is 11 choose 7. So that is the denominator for our probability in we can say that, right? Okay. So we'll find what this is so that we don't have to really calculate it every time. So it is 11 C7. All possible combinations for us is 330. Okay. Now, let's look into the question in greater details. A committee of 7 is to be chosen randomly from 3 students and 8 teachers. Construct a table to show probability distribution of the number of students chosen. What is the expected number of students on the committee, right? So what we will do here is, since we need to find expected number of students also, so we'll kind of make a table. In this table, we'll write possible values of our random variable, and then we'll kind of calculate their probabilities. That becomes a probability distribution, and then we'll multiply by x and add them up to find the expected number of students, right? So this column, let it be for x. Since we have only 3 students, a committee has 7, so maximum can be 3 students only. So the possible values for x are either 0, that means all the 7 selected are teachers, none of them is a student, or we could have 1 student, or we could have 2 students, or we could have 3 students, right? So these are the possibilities for x value, all the values of x, right? Now let's find out their probabilities. Okay. Now in the first case, if you do not choose any student, that means out of 3, none has been taken, and out of 8 teachers, 7 have been selected. Is it okay? So probability will be this times this divided by the total number of combinations. That means out of 11 we will be choosing 7, right? So that becomes the probability, right? When we select 1 student, then 1 student is selected from 3, and then 6 will be selected from the teachers. So from 8 teachers, 6 will be selected. divided by total number of combinations, which is 11C7. For 2, we will be writing this as 3C2, 8C now 7 to make it 7, 5 divided by, so this is for division, right? 11C7. And for 3, we are saying all 3 are students, right? So none of them is a teacher. 4 of them are teachers. 4 plus 3 is 7. And this divided by 11C7, right? So those are the probabilities, right? So, and we will kind of extend this, and we'll multiply these. This is less space, so I'll kind of write equal to, calculate with the calculator the answers, and write down these answers here, right? So we have 3C0. So let me write a general formula here, which will help us to quickly find the values. Now 6C0, within brackets we have 8C7, so 8C7, and then we'll divide this by 11C. Let me write that also in brackets. Good to write them in brackets. Sometimes I feel that we get errors when we don't use brackets. Okay, now when it is simple multiplication and division, normally you don't get errors, so you could have done without that also. Anyway, we get 4 over 165. Now I would have preferred to write it as 8 over 330. The reason is it becomes easier to add. So 4 over 3, I'll write this as 8 over 330, right? So I'm just multiplying by 2. I don't really want to write in that form. Anyway, so let's do the next one. So what I'll do now is since I have inputted the formula, so now we'll change the values. So we have 1 here and 8C6. 6 there. The denominator is same, and that is equals to 14 over 55. Okay. Let's write down what we get here. 14 over 55. Okay, no problems. And then we have 3C2. Okay, so we have 3C2 now, and this value is 5, and that gives us 28 over 55. So this is twice this, 28 over 55. And the last one is 3C3, and that becomes 4, and this is equal to 7 over 33. Right, so these are the different values for the probability distribution, right? So when you combine these columns, let me use a different ink here. So we get the probability distribution, right? So this gives you probability distribution. Is it okay? That much gives you probability distribution. And when you add this up, you will get 1, right? As expected, you should always get this as 1. You can try this out, right? Now, so we have this probability distribution done. Now we will now find out what is the expected value. So that means x times the probability distribution. This is what we will do. So the first term will give us 0, right? 0 times this. 1 times this will get 14 over 55. 2 times that number, so 2 times 28, 56, right? So 56 over 55. And 3 times 7 is 21, so we get 21 over 33. Now if you sum these up, right? So if you sum these up, you get the expectation, right? So this total is expectation. So let's add them up. So we have 14 divided by 55 plus 56 divided by 55 plus 21 divided by 33 equals to, and in decimals, which is equals to 21 over 11. So the expectation here is equals to 21 over 11, or in decimals it could be written as 1.9. Okay, so that is the expectation in this particular case. I hope the steps are clear, right? That is how it could be done. It is important to understand that this belongs to the distribution of hypergeometry, right? That is the distribution which really characterizes that particular question. I'm Anil Kumar. You can always share and subscribe my videos. Thank you and all the best.